This lecture video is about compound inequalities, and so we're going to look at solving some linear inequalities, but before we can do that, we need to look at what two things mean. The first one is the intersection of two sets, and the second one is the union of two sets. So the notation that we use for the intersection looks like a big capital U upside down. And the intersection means that you need whatever is in the intersection has to be in both of the original two sets. The union, the symbol for that is a big capital U, and the union is just taking everything in one set and adding it to another set. So intersection is the item has to be common to both sets to be in the intersection. Union is if it's in one or the other, it ends up in the union. So we'll take a look at what that means. And one way to look at this is with what we call a Venn diagram. And so Venn diagram is similar to these down here, and normally we also have like a rectangle around these two ovals. And so inside this big box is what we would call our universe, whatever our universe might happen to be. So we can define our universe to be whatever we want. The universe could be all students at Inver Hills. The universe could be the population of Minnesota. The universe could be whatever we define it to be. And so most of the time in math, we're going to define the universe to be the set of all real numbers. And then these ovals are representing some little section of those, whatever we define our universe to be. So our universe, if we wanted to talk about Inver Hills, could be all the students at Inver Hills, and one of these sets could be the students in our class, and then the other set could be students in some other class. And then the intersection would be the students that were in both classes. So let's talk about numbers. And so let's say we had the set 2, 3, 4, and we have the set 4, 5, 6. So similar to the sets we're going to talk about down below, but I just wanted to use these diagrams here. Okay, so we're going to say that our universe is the set of all real numbers. And set A is this first set, 2, 3, 4, and set B is this second set, 4, 5, 6. And this first oval is going to represent our set A, and the second set is going to represent B, 4, 5, 6. So we have 2 and 3 in A, and we have 5 and 6 in B, but 4 is common to both of them, so we would put that in the intersection. So this middle section is what we call our intersection, and we use an upside down U to denote that. And then the union of the two sets would be, and I'll shade that in red, the union would be all of this, even the intersection part. And so the union would be with a capital U. Okay, so let's just go down and take a look at some of our examples now. So if A is the set X such that X is an even integer, B is the set X such that X is an odd integer, C is the set 1, 2, 3, 4, and D is the set 3, 4, 5, 6. We want to list the elements of each of the following sets. So our first one is C. This notation, remember, means intersected with D. So intersection, remember, means it has to be in both C and D. That's what intersection means. C is 1, 2, 3, 4. D is 3, 4, 5, 6. So the elements of this intersection are only those numbers that are in both C and D. And both of them have 3, and both of them have 4. So our intersection would be the set 3, 4. Okay. Now we want to do the intersection of A and B. So that means that it has to be in both. A is the set x such that x is an even integer, and B is a set x such that x is an odd integer. So in order for a number to be in this intersection, it would have to be both an odd integer and an even integer. And so there is no number that's both odd and even, so that would be the empty set. Our next one, B union C. So union means as long as it's in B or C, then it's okay. The other word for intersection would be and. So it has to be in A and it has to be in B. Union is it can be in B or B and C to be part of this union. So B is a set x such that x is an odd integer, and C is a set 1, 2, 3, 4. So as long as it's in one or the other, it's a part of this. So it's a set x such that x is an odd integer. And also, C has some numbers that are not odd integers, so we'll need to add those to our set. So 2 and 4 are also in this union. And then C union D. So everything that's in C, so 1, 2, 3, 4, plus the stuff that is in D, which is the 5 and 6. You never list numbers in a set twice. So just because we're adding these two sets together, we don't list the 3 and the 4 twice. We only list them the one time. Okay. So how does that relate to what we're doing now? So we're going to have, sometimes you're going to have and statements, and sometimes you're going to have or statements. And so if you have and, it means that this has to be true and this has to be true in order for it to be part of the solution. For the or statements, this can be true or this can be true. Either one of them will result in a true statement. So I'm going to go back to my black pen. And so I always solve these by putting them on a number line first. So take the two numbers. We have a 1 and a -3. Put them on your number line in the proper order. So -3 is to the left of 1 on the number line, so just make sure that you put them in that order on the number line. And now we're just going to graph the inequality that's there. The first inequality is x is less than or equal to 1. So because there's an equal sign with the less than symbol, we use a square bracket. Or you can also use a filled-in circle if you like a filled-in circle better. So it's everything to the left of 1 and including 1, that's why we use the square bracket. And x is greater than or equal to -3. So I'll just use red to graph x is greater than or equal to -3. So that's everything to the right of -3. And we use a square bracket because this inequality has the equal sign in it. Okay. So both of these have to be true. With the and statement, they both have to be true in order for it to be part of the solution. So the solution I'll put in blue, and the solution is the intersection, and is the same as intersection. So it's the place where the red and the black intersected. And so that was everything between -3 and 1. So our next example, x is less than 1 and x is greater than 4. So we'll put this on a number line. And our two numbers are 1 and 4. The first inequality says x has to be less than 1. There's no equal sign, so we use a round bracket. Less than means everything to the left of 1. And then I'll graph the other one in red. And so this is everything greater than 4, so that's everything to the right of 4. We use a round bracket because there's no equal sign. Or if you want to use open circles for less than or greater than, you can do that as well. Remember, this is and, so this has to be true and this has to be true in order for it to be part of the solution. And so that's the intersection. Both of these were intersections. And the black and the red don't intersect anywhere, and so there is no solution. In our next example here, we have x is greater than or equal to -3 and x is greater than 2. So put -3 and 2 on your number line. And we're going to graph the first inequality. X is greater than or equal to -3. So it has the equal sign, so we use a square bracket. And it's greater than, so it's everything to the right of -3. The next one says x is greater than 2, so we'll do that one in red. It's strictly greater than, so we use a round bracket, and it's everything to the right of 2. And means intersection, because this and this has to be true in order for it to be part of the solution. And so in blue we'll do the solution to this. So this one includes 2, but this one does not include 2. So we need a round bracket at 2, and then it was all the intersected parts. Okay, so the solution then is going to be a round bracket 2, and it goes up to positive infinity. In our next example, we have x is greater than or equal to -3 or x is less than or equal to 3. So as long as one of those is true, then it's part of the solution. So put -3 and 3 on your number line. And or means union. So if this or this is true, either one of them, it'll be part of your solution. So the first one is x is greater than or equal to -3. So that's everything to the right of -3. And we use a square bracket because there's the equal sign. And then in blue or in red, we'll graph the other one. And this one is x is less than or equal to 3. So we use a square bracket, and it's everything to the left of 3 because it's less than. So basically, when you have the or statement, any part of the real number line that got shaded is part of our solution. So the number line got shaded all the way to the left and all the way to the right, so our solution is -infinity to infinity. And I'll put that back in blue. So anything that got shaded, so that's everything on this one. Our next one, x is less than -1 or x is less than +1. So put -1 and 1 on your real number line. And the first one is x is less than -1. There's no equal sign, so we use a round bracket. And it's less than, so it's to the left of 1, and then x, or -1, and then x is less than +1, so that would be a round bracket and everything to the left there because it's less than. And so it's anything that got shaded as part of our solution. So we would want to go from 1 all the way down to -infinity. You always list the smallest thing first, and sometimes it's helpful if you put the infinity symbols to the left and to the right on your number line. And so we're going to go from -infinity up to 1. And we're using a round bracket with both of those because this infinity always gets a round bracket, but this gets a round bracket because there's no equal sign. And our last one of these, again, put the two numbers on a real number line, and in the proper order. We have x is greater than or equal to -2, or x is less than or equal to -3. -3 is to the left of -2. And our first inequality is x is greater than or equal to -2, so that's everything to the right of -2, and we use a square bracket because of the equal sign. And our second inequality is x is less than or equal to -3. So that's everything to the left of -3, and we use a square bracket because of the equal sign. So now the solution is anything that got shaded. So this part got shaded, and this part also got shaded. So the solution is in blue, and again, if the infinity symbols help you, write those up there, and then you can see what this first interval is. It's -infinity to -3. Infinities always use a round bracket. Square bracket with the 3 because we had an equal sign there. And then we would want to join these two sets together, so we use the union symbol. And then we pick up at -2. with a square bracket because this has the equal sign, and then we go up to this positive infinity. And so there is our interval for the last one. And that finishes up our lecture on solving compound inequalities. Let me know if you have any questions. Thanks.